Earlier today, a large eruption of the Mayon Volcano in the Philippines occurred, sending pyroclastic flows sweeping multiple kilometers downslope and ejecting sizable volumes of ash. By the time the pyroclastic flows had ceased, they had traveled up to 4 kilometers or 2.5 miles downslope, marking the longest such several hundred degrees scorching hot gas current the volcano had produced since its latest eruption began in December 2025. While geolocating the precise pyroclastic flow extent is difficult, it seems to have followed this path, largely confined to the Mi-isi gully. This might surprise some people, but what we all just witnessed was not a large volcanic eruption in the traditional sense, as no major explosion originated at Mayon's summit. Rather, a section of Mayon's slowly moving lava flows collapsed on its steep slopes and broke off, causing a release of pressure which released trapped gases and volatiles along with lava fragments downslope, and these transitioned into generating the lengthy pyroclastic flows which were observed. These pyroclastic flows were gas-poor due to their origin, so for all intents and purposes their speed was on the very lower end of how fast pyroclastic density currents can travel. As for the ash which did fall, that did not primarily originate from Mayon's summit. Instead, it originated mainly from the co-ignimbrate plume, or upward-moving plumes of lighter material which rose off of the pyroclastic flows and just-in-place pyroclastic flow deposits. This resulted in some areas receiving a continuous dusting of ash rather than the spotty coating Mayon's ashfall had caused at times since its now nearly 5-month-long eruption began. Thankfully, the pyroclastic flows were completely confined within Mayon's permanent 6-kilometer danger zone, where everyone that previously lived within it was evacuated many months ago. Regardless, this marked Mayon's longest pyroclastic flow since December 2023, as yes, Mayon has produced far longer pyroclastic flows in the past, just not with its current eruption. The reason for this is that Mayon's overall ongoing eruption is on the very lower end of its potential explosivity. Whether more lengthy pyroclastic flows might soon occur is uncertain, but at least additional lesser-length pyroclastic flows in the same Mi-isi gully in my opinion are quite likely in the near future. The reason that this gully was the site of the pyroclastic flows which struck was twofold. One, because the lava lobe within it was advancing the fastest of the 3 lobes of molten rock Mayon's ongoing eruption has created. And 2, the specified advancing lava flow may have potentially passed through a very steep segment of the gully which overlaid much rubble related to Mayon's 2023 eruption, marking an overall unstable spot. This suggests that more collapses could occur in the same gully that also generate pyroclastic flows, but this is just my opinion. Collapses at the other 2 gullies with lava flows could also occur during the current eruption, but it is uncertain if this will happen. While the fresh ash on the ground may cause some minor disruptions, I haven't seen any evidence of it accumulating to thick enough quantities in my opinion to signify a major danger to electrical wires, buildings, or other infrastructure. I want to note that Mayon has produced more than 1,000 pyroclastic flows so far during its ongoing eruption, but all of these were smaller than what was observed after 5 p.m. on May 2nd, 2026. I am making this video while on a cruise ship while on vacation, so I apologize if the audio quality is a bit less optimal. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube for supporting my work.